Okay, so this is my second video for whilst you're at home working on your own. I'm going to go through how to work the questions in exercise 1D today for the Pure chapter in the Edexcel textbook. And that's about something called partial fractions, which you won't have come across before. This is brand new, but is fairly straightforward to understand. As I said in the last video, if you've got any questions, any queries, anybody not sure how to answer a question, just let me know. Remember, there are worked solutions on the online textbook. You've got the steps for each question, so if you've got the answer wrong in the back of the textbook and the answer's in the back, then you can always look at the worked solutions, and most of them are correct. There are the odd mistake. There is the odd mistake, but most of it's good. So the whole idea of partial fractions is as follows. I've actually started off with another addition question that we looked at in the last lesson, and if we add these two fractions together by finding a common denominator, you'll see why I'm talking about this in a minute. I'm going to times the left and the right by the opposite denominator to get a common one. We've just practiced doing this in exercise 1B or 1C. I don't know why I keep writing that all the way over there. Oh, it won't let me split it. Anyway, I'll keep going. Expand the tops, so that's going to be 3x minus 6 plus 4x minus 2 over 2x minus 1 and x minus 2. And if we collect them together, that's going to give me 7x minus 8 over 2x minus 1 and x minus 2. So what this means is, now this doesn't seem like a very exciting result, but what this means is that 3 over 2x minus 1 plus 2 over x minus 2 is the same as 7x minus, 7x minus 8 over 2x minus 1 times x minus 2. They're the same thing. They're equal to each other. I could write them as an identity. Now that's actually a really important result, because what that means is, and we've only ever gone from something like the left hand side to the right hand side, but partial fractions and splitting into partial fractions is all about going from something that looks like the right hand side and making it become something like the left hand side. So writing the question the other way around, going back to front. We would start with, like I said, 7x minus 8 or some other fraction that looks in this kind of form, and be able to split it into the two fractions. Now, we could probably guess what part of the answer is going to look like straight away. If you compare the left and the right, the two brackets that we've got here become the two separate denominators of the fractions in what's going to become our answer. The tricky part, as I've written down at the bottom here, the tricky part is working out what those numerators are going to be. But what we do know is that if I introduce a new question, you could probably guess part of the answer. It would be reasonable to expect the answer to become something that we don't know. Don't know what this 3 and the 2 will end up being, but it will be something over x plus 3. I'm going to write a over x plus 3 plus something else, a different number, might end up being the same, but we're going to assume it's a different number over x minus 2. And that will always be true. If I have a double bracket or two brackets being multiplied together and an x term or a linear function, I should say, on the top here, that will always split into a over x plus 3 plus b over the second bracket, and in this case it's x minus 2. And that's half of the answer. Our job though will be to work out the values of a and b, and I'm going to show you how we work out a and b. And it's quite nice, it's quite straightforward. We're going to use the fact that they're identical, they're true for all values. The left hand side will be equal to the right hand side for all values of x. So, in fact, let's go with this question. Let's work out what a and b are for this question. So the question was 2x plus 1 over x, what was it? X plus 3, x minus 2. And we are going to say that that is going to be identical to some number over x plus 3 add another number over x minus 2. So how do we work this out? Well, what we're going to do first is we are going to get rid of the denominator of the left hand side. Now, because this is an identity, I can do, if I do something to the left hand side, it's just going to happen to the right hand side, just like with an equation. So I'm going to multiply both sides by the left hand denominator. That will obviously disappear from the left hand denominator and turn the left hand side into just 2x plus 1. When I times this term by x plus 3, x minus 2, and I'll just write it in this time just so you can see it happening, the x plus 3 terms are going to cancel, and this will just become a lots of x minus 2. Something similar is going to happen to the right hand side, to the second fraction, except it's going to be the x minus 2 that cancels, and we will have b times x plus 3. So if this statement at the top is true, which we know it is, the second statement is also true, and that's much easier to look at, much easier to work with. So now we're going to use the fact that this is an identity, and as we said earlier, that means that it is true that the left hand side is equal to the right hand side for every single value of x. Now what I'm going to do is set x to be a particular value that's going to allow us to work out a, and then another value that's going to allow us to work out b. And I'm going to start off by letting x equal minus 3. Now I'm just going to pause there for a second. Can you see why I want x to be minus 3? What is going to happen when x is minus 3? And what's going to happen is that this bracket here will be worth 0. So we're going to end up with b times 0 just when x is minus 3. But because this is always true, because the left hand side has to equal the right hand side for any value of x, that's going to allow us to make b disappear and work out a. So I'm going to substitute that in now. That's going to give me minus 6 plus 1 needs to be the same as a lots of minus 3 take away 2 more plus 0. That b term's gone. That's why I set x to be minus 3. If we simplify this, this gives us that minus 5 is equal to a times minus 5, and that means that a has to be the number 1. So that's set now, that's guaranteed. We've worked a out to be positive 1. I'm going to do the same thing again to help me work out b this time, and just think for a second, what am I going to let x be now in order to work out the value of b? And I'm going to let a equal 2. I'm letting a equal 2 so that this bracket now disappears, and I'm going to be allowed to work out b. So when x is equal to 2, I'm going to have 2 times 2, which is 4, add on 1 on the left, and on the right I'm going to have 0 for the a term. So it would be 2 times 0, so that's just going to go, times b lots of 2 plus 3. So that's 5 equal to 5b. So a really simple example, in both of these cases here, b is equal to 1 and a is equal to 1. That's nice and straightforward, but what that now means is we can go back and write out the fact that 2x minus 1 over x plus 3 x minus 2 can be written instead as 1 over x plus 3 add on 1 over x minus 2. And that is going to be really important for the maths that we end up doing later on in the year. There's 2 really good reasons why we do this. You've not learned the techniques that we need to put this into use yet, but we're just building the foundations. This is only chapter 1, and we will come back to this later in the year on 2 separate occasions to see why this is better than this. So let's go to that second example that I showed you for a second earlier. We're going to now split 5 bracket x plus 2 over x plus 1 x plus 6 into partial fractions. We are going to start off exactly the same as we did in the previous example, and we are going to say that this can be written as a over x plus 1 plus b over x plus 6. Now again, if you want to pause the video and try and work this out yourself, see if you've understood my example on the previous question. If not, don't worry, you can watch another example. I've got more to come. But the first thing I'm going to do in order to solve this is multiply by this left-hand denominator again. When I do that, the x plus 1s will cancel in the a term to leave me with a bracket x plus 6, and the b term will end up being multiplied by x plus 1 because the x plus 6 terms will cancel. I'm going to let x equal minus 6 first. No need to expand these, I can leave that 5 where it is, it's going to be easier to work with. Minus 6 add on 2 is minus 4. The a term is going to disappear. I'm finding out b first, and that's going to be minus 6 add 1 is minus 5. So minus 20 needs to equal minus 5b, which means b is positive 4. We need to go back up here and see what else to let x. I'm going to let x equal minus 1 next. I'm going to have 5 lots of minus 1 add 2 is 1. And this is going to allow me to work out a. So that's going to be a bracket 5. So a is 1. Which means we can go back to the question and we can say that 5 lots of x plus 2, don't forget to answer the question, 5 lots of x plus 2 over x plus 1 x plus 6 is equal to 1 over x plus 1 plus 4 over x plus 6. And if you've got time in an exam, you could multiply add these 2 terms together, give them a common denominator and add them, and hopefully you would see that you'd end up with 5x plus 10 on the top. Some people aren't sure what to do when it's an x term, not a bracket, so I'm just got an example of that. If you want to have a try on your own first, go ahead. And here's my solution. So what I'm going to do is just set the first term to be a over x. That will be the first fraction. The second fraction is going to be b over 3x minus 2. Same as before, I'm going to multiply by the denominator on the left, which is going to leave me with 12x minus 6 is equal to a bracket 3x minus 2 plus just bx. I'm going to let x equal 0 first, because then that will make the b go. When x is 0, this will be 0, so that's just minus 6 on the left equals a bracket minus 2. So a is equal to 3. And then the second one this time is a little bit trickier. In order to make the a's bracket equal 0, it's like when you solve a quadratic, it's going to be x, or 3x equal to 2, so x needs to equal 2/3. Remember, you've got your calculator, so it's not too horrendous the fact that we've got a fraction there. We're going to have 12 lots of 2/3 minus 6 on the left equal to b times 2/3, 2b over 3 on the right, because this time the a term is going to be 0. 2/3 of 12 is 8, so we've got 8 minus 6 is 2. And if I times by 3 and divide by 2, I've got that b is equal to 3. So the answer is that 12x minus 6 over x bracket 3x minus 2 is equal to 3 over x plus 3 over 3x minus 2. Okay. Now I've got one final example for just to show you. If the examiners are feeling particularly mean on a day, they might give you 3 brackets to do instead of 2. Same principle. We're going to split this into 3 fractions. We're going to need 3 letters. It's just going to take you a little bit longer. So we're going to have a over x plus 1, b over 2x plus 3, and c over x take 3. If you want to have a pause again and work this out yourselves, oh, I've lost my x there, then you can go ahead. But in order to answer the question, I'm going to multiply by the left hand side. It's going to make these a little bit more complicated. I'm going to, this time, only the x plus 1 term is going to cancel, so I'm going to have a times 2x plus 3 and times by x minus 3. B is going to be times by x plus 1 and x minus 3. And c is going to be multiplied by x plus 1 and 2x minus 3. I'm going to need to let x equal 3 different things. Let's let x equal 3 first. I'm going to save this one to last because it's going to be a complicated fraction. When x is equal to 3, I'm going to have 36 is equal to, this term's going to go, this term's going to go as well. This is going to let me work out c. C is going to be 4 when x is 3. This is going to be 4 times 3. So that's 12. 12c is equal to 36. So c is equal to 3. Let's let x equal minus 1 next. This time b and c are going to go, and it's going to let me work out a. So that's a times minus 2 add 3 is 1. And minus 1 minus 3 more is minus 4. So we've got minus 4a is equal to minus 12. So a is 3. We like 3 on these examples, don't we? Let's see what b is. Is b 3 as well? last job to find b, and we're going to do that by letting x equal minus 3 over 2. On the left hand side, 12 lots of minus 3 over 2 is going to equal, a and c are going to go, we're going to find b. b times minus 3 over 2 plus 1 is minus a half, and the other bracket is x minus 3, so minus 3 over 2 minus 3 whole ones is the same as minusing 6 halves, so that's minus 9 over 2. Minus 18 on the left. You can obviously use your calculator for this. I've not got mine with me, so I'm doing it all in my head. Hopefully I've not made a mistake yet. Is equal to positive 9b over 4. And in order to solve that, I'm going to divide by the 9 first to keep the numbers small, because that's just minus 2. So b hopefully is equal to minus 8 if I've not made a mistake there. Yeah, I think that's right. So then our 3-term partial fraction is 12x. Remember to write your answer down. 12x bracket, what were they? X plus 1, 2x plus 3. And x minus 3 is equal to, it was 3 over x plus 1. It is minus, because it's negative, it just means it's a takeaway, not an add. That's quite an important point to realise. You're better off writing this rather than that. I wouldn't do that. Write it as a subtraction instead. And c was 3 as well. So that's the final answer. So you should be able to do most of exercise 1D now on page 11. There is one slight variation to this, and that is when, and I'm going to talk more about top-heavy fractions when we do the polynomial division work, but sometimes you get a top-heavy fraction. Now a top-heavy fraction in algebra is slightly different to a top-heavy fraction in numbers. Obviously 9 over 4 is a top-heavy fraction in numbers. In algebra, a top-heavy fraction is counted as one where if the leading term in each of the fractions on the top and the bottom, if the top power is equal to or more, doesn't just have to be more than, it can be equal to as well. If it's equal to or more than the leading power of the denominator, then it is called a top-heavy fraction. And if that happens, when you split your partial fractions, you won't just have an a over x plus 4 and a b over x plus 2. You will have an integer term by itself as well, in the same way that this would be written as 2 whole ones and a quarter. Okay, so this is acting as my kind of the integer part, the 2 plus the. And we have to remember that might happen. Now, hopefully, if you had a question like this in the exam, they would help you out a little bit by reminding you that there's going to be an integer part by itself. And they're going to tell you how to form your answer. If you're really unlucky, they won't tell you. And you would have to spot it for yourselves that we are going to have an integer term in this question because it's counted as a top-heavy fraction. You will answer the question exactly the same as we've answered all the other partial fractions questions. We are going to just do what we're told. They're telling us that this can be written in this form. So we're going to set the left-hand side equal to the right hand side, we're going to multiply by the left hand side of the denominator, the denominator of the left hand side, and we're just going to treat it the same as all the other questions. There are obviously 3 terms to work out, and when I times by a, both fractions are going to stay. So it's going to be fairly straightforward for the most part until we need to come to work out a. That's going to be x plus 2, and that's going to be x plus 4. So we can do what we'd normally done to work out b and c, but we're going to have a new step to do to work out a. I'm going to, as we've done on all the other questions, let x equal -2 first. That's going to make a disappear and b disappear, and it's going to let us work out c. This is going to be -12, I think. Let's do that properly. 4 2s are 8. 8 minus 28 is -20, plus 8 is -12, yeah. So C is -6. So there's job 1. Let's let x equal, is it minus? Yeah, let's let x equal -4 next. Right. This is great fun without your calculator. And the a is going to go again. This time we're going to have b times -2. That's 32 minus 56 plus 8. That's 40 minus 56 is -16 equals -2b. So b is 8. And now we're in a little bit of a pickle. We don't have another number to choose for x, but we still need to find out a. But what we can do is remind ourselves that this is actually an identity, which means it's true for all values of x. We chose particular values of x to help us eliminate part of the right hand side, but it's true for any value of x. So if I choose one more value of x that I've not chosen already, now that we know b and c, there is only one unknown. We only don't know a. So if I say let x equal something nice and easy, let's let x equal 0. I could have chosen 1 or -1 or 2, just something you've not chosen already. Then we can work out what a is because we know b and c. 0's easy. 0's easy because the left hand side is 8. We're going to have a times by 4 and times by 2. We know b is 8, so we can fill that in, and that's going to be times by 2. And we know c, we worked that out as well. C was -6, and that's going to give us 0 plus 4 is 4, and we've only got one unknown. So we've got that 8 needs to equal 8a plus 16 minus 24. That's going to be, if I subtract that, that's -8, so that's going to give me 16 equals 8a, so a is equal to 2. Now, I actually could have worked that out much quicker, and you'll see this, as I said before, more when we do the polynomial division. But just as a little kind of sneak preview, if I expand the bottom here again, a is always the answer to this term divided by this term. that's only true when they're both x squared. If this had been an x cubed and an x squared, that would not be true. But when they are equal power, the answer is the power, the coefficient of x squared on the top divided by the coefficient of x squared on the bottom. In that case, it's 2 divided by 1, which gives me 2. So I could have found that out a little bit quicker, and you'll be allowed to do that in your exam. Just if you're gonna do it, just don't mess it up. Make sure you get that right. Some people think it's always just this number, but if that had been a 6, say, A would have been a third, not just the 2 that's sat there. So we've got all the information we need now. The final answer is the 2 plus the 8 over the first bracket and minus the 6 over the second bracket, so that's x plus 4 and x plus 2. And again, if you've got time in an exam, I would always recommend that you actually work that out. You add them back up together and check that you do have what you should have from the original question. Okay, so you should, as I said before, you should now be able to do every question on exercise 1D. That starts on page 11 in your textbooks. The work solutions in the online textbook are really useful. They've got all the steps, as well as the answers, the quick answers in the back. As I said at the beginning, if you've got any problems at all, just give your teacher a shout or leave me a comment, and I'll try and answer them for you.